Okay, so we're going to start with section 9.1, applications involving right triangles. Okay, so go ahead, if you don't have this already, you can write it down. Honestly, the only part that's different from what we have been looking at before is this little part here about angle A plus angle B should be equal to 90 degrees. Obviously, that's only true if we're talking about a right triangle. And other than that, it'll be A plus B plus C is equal to 180 degrees. All right, so we're gonna actually go ahead and do this over in the whiteboard. I'm gonna try to give you as much hands-on as possible. So let's go over to the whiteboard. All right, so if we are given B equals 4 and A equals 35 degrees. Oh, my numlocks wasn't on. And unfortunately, I have to spell things out because I'm not going to go through and try and find the angle or the little symbols. Okay, so here's hoping we have a shape that looks kind of like a triangle, but we do not, so we'll just draw it this way. All right, and we can pretend that's perfect. We all know it's not. Okay, so we're gonna mark that it's a right triangle. And we were given 4 and 35 degrees. And we have to find everything else. So what's the easiest one to find?
Beta or B?
Yeah, the missing angle. So if we want to find the missing angle, we're just going to do 90 minus their given of 35. And that's going to be equal to your missing angle. So what's your missing angle going to be?
55.
Perfect. Okay, 55 degrees. Okay, now we just have to figure out our two sides. So to do that first one, we're gonna go with the tangent of 35 degrees equals A over 4. So then A, if we rearrange that, is going to be the 4 times tangent of 35 degrees. I apologize if I'm going a little fast. Like I said, you guys can watch this later on YouTube or Canvas when I get it up on Canvas. But we just have to move quick through chapter 9. Just don't want us to run out of time. Okay, so to find the last one, we're going to use cosine 35 degrees equals 4 over little c. So then little c is equal to 4 divided by cosine of 35 degrees. So then c is equal to 4.88. Okay. All right. Hoping you all got that. If not, I will show you really quickly in the example as well. So as you can see here, give you their nice little right triangle. They explain how to find B. And then they also explain how to find A and C. And then they just break it down. So here they're finding it. Okay. All right. So this is another one. This time they give you 4 is A, B is 2, and you have to find C, A, and B. So what can you do first? What's the easiest one?
The hypotenuse.
The hypotenuse. Very good. So just knowing what we're given there, we're going to find it to be the square root of 20 or 2 square root of 5, or you can use the decimal of 4.47. As far as what Pearson would want, you'll just have to see each question might be different. All right. To find the missing angles, we're going to use tangent inverse of 2, and that'll give us A. And then once we have A, we can turn around and use the fact that A plus B equals 90. So then B is going to be 2.66. Okay, so make sure you write that example down. And if I go too fast, please use the video. You can pause it. Okay. All right. So we're going to move on to some application problems. I want you guys to go ahead and take your information down, and then we'll go over to the whiteboard. So it says here, finding the inclination of a mountain trail. A straight trail leads from Alpine Hotel, which sits at an elevation of 8,000 feet, to a scenic overlook with the elevation of 11,100 feet. The length of the trail is 14,100 feet. What is the inclination or grade of the trail? In other words, they want to know what the angle B is in the figure. And just so you know, in Pearson, they probably will not give you this length of 3,100 feet. They'll give you the 8,000 feet and the 11,100, and you'll have to know how to calculate that height. Okay? Does anyone have any ideas before we switch over to the whiteboard on what your approach would be?
I think it's sine -1 of 3,100 over 14,100.
Yep, exactly. So I won't even take it over into the whiteboard. You got it right. So, like I said, with Pearson, you probably would have to find this amount yourself. You wouldn't be given it necessarily. And if not in Pearson, then definitely with the Chapter 9 exam, you probably will be given something similar. and you'll have to know to find that. Great job, Julia. Okay. So we're going to go ahead and move on to example 3, which talks about a lighthouse. This example I thought was kind of cool. I know that might make me sound dorky, but I just thought it was pretty neat. So not only do we have to find the mileage, but we have to find it kind of twice. So let's just take a look at it real quick. A lighthouse stands 100 feet high on a hill that's 300 feet high. So obviously the lighthouse is going to be 400 feet. A brochure states that the light can be seen on the horizon about 26 miles distant. Verify the accuracy of this statement. I don't know about you, but when I read that, I kind of feel like that's fairly significantly far, so I don't know how it's going to turn out. So if we take a look, we know that theta is the central angle positioned at the center of the Earth. You can literally tell that. They have sliced the Earth. Here's the lighthouse at 400 feet. And so we know that the radius of the Earth is 3,960 miles. We have to add in the height of the lighthouse. So with some of the chapter 7 exam, some people got the adding of the +3, and then some people put it outside, some people put it kind of ignored it. So we have to remember to add in that extra height, okay? And here it is right here. And then that they kind of reduced it weird. So you kind of have to be careful here if you're just looking at the slides. You can't just go straight from one to the other. So then we end up with, they gave us the degrees and then also the minutes. The minutes kind of help us out because we have to kind of figure it out using 2 options here. You have nautical miles or statute miles. To find your nautical miles, we're going to take the angle and find it in minutes. Well, we already kind of did that on the last slide. So your nautical miles are 21.27 nautical miles. And then to find your statute miles, you have to find S equal to R times theta. So once you do your conversion, you're going to end up finding that you have 24.5 miles. So are either one of those equal to 26 miles? The nautical or the statute miles that we found, are either one 26 or more? We have 21.27 nautical miles and 24.5 statute miles. So neither one is going to be equal to 26. So that means that you have to say that the brochure overstated the distance. Okay. Any questions on a problem like that? You have to remember to make your statement at the end. You can't just, write down 24.5 miles and 21.27 miles. First off, if you only give me one of the mileage, you're not getting the whole credit. I'll probably only give you half the credit. And then this statement will also be extremely important because when you have an application problem, you have to give it kind of a little bit more of an applied feel when you answer it. Does that make sense? Okay. All right, so for the last portion of this, for this presentation, you have to write down this definition. In navigation and surveying, the direction or bearing of, say, of like a plane from the origin to a point equals the acute angle theta between the ray OP and the vertical line through O, which is the north-south line. So if you take a look at what they give you here, they're giving you 3 examples and then you have to kind of figure in the last one. At first, I thought they just kind of forgot it, but it's because they turn it into a problem. So if you take a look at this, from off the origin, You always have to go off of this north-south line. You can't really go from east-west. East-west will always be your secondary direction, and your primary direction will be north or south. So for P1, we're sitting at 30 degrees off of north towards the east. Okay. For P3, we're at 70 degrees off of north towards the west. Okay, for P2, we're sitting at 50 degrees off south towards the west. So how would you guys describe P4?
degrees to the south.
So 20 degrees from the south, where is it heading?
East.
Hmm? Okay, so that's how you finish that one out. You have to do S for south, 20 degrees to the east. So that's how you finish out this bearing system mapping. Okay. All right. Here's the last example for this section. But like I said, we are going to move on to the next section, so don't go anywhere. So we have a Boeing 777 aircraft taking off from Nashville International Airport on runway 2 left, which has a bearing of north 20 degrees east. After flying for 1 mile, the pilot requests permission to turn 90 degrees and head towards the northwest. The request is granted. After the plane goes 2 miles in this direction, what bearing should the control tower use to locate the aircraft? So if we draw, where did I do my drawing at? Okay. Did everybody get a chance to write their information down before we go to the whiteboard? Okay. We can come back to it, but I just want to kind of have you guys look at this. So if we draw, right? And then we have our plane. We'll say our plane is blue. It heads off in that direction, which is labeled north 20 degrees to the east. Okay. So then they want to go after 1 mile, they're now going to head this way. So what you want to find out essentially is from this origin point, and you're going to have to pardon my very horrible drawing. You should draw it as a dotted line. Obviously, mine does not look like a line at all. So that is not a pretty example. Okay, but this is Q. This was P right here. Okay, so you had your runway. It was right here. So the question is, this is 20 degrees, and this is the origin. So if you were to figure out how you would basically describe Q, north south, east, west. What do you guys think we would have to do? What's the first thing you guys feel we should find? Well, we need to find a new theta, right? Okay, so that's going to be our first thing. So we're going to have tangent theta. And we know that they went for 1 mile and then they turned directions, 2 miles. So if we're using tangent, that's going to be 2 over 1, which is 2. So theta equals tangent inverse of 2. So then we're looking at 63.4 degrees. But that includes this original 20 degrees, right? It's kind of like this point from here to here is your new theta. But we can't include that 20 degrees because where are we supposed to look at when we're talking about bearings? From what primary purpose do we talk about bearings at? Do you guys remember? We want to consider it from the north-south axis, basically, okay? So we kind of have to take 20 degrees off of this. So 63.4 minus 20 degrees is going to give us 43.4 degrees. So now that we have that, we know it's coming from the north. Where is Q headed? If you had to pick where Q was headed, we know it involves the north. What other directional does it involve?
West.
Very good. Okay. So if you were to put that in words, you would, the new bearing of the 7, here, I'll type it out for you too. So in words, it would be the new bearing of the 777 is now from O to Q north 43.4 degrees to the west. Okay, and you make sure that you write it like this. Okay, excellent. Right. Any questions on 9.1? Okay, you can see they had their nice little drawing. It's a lot better than mine. All right, but they solved it the same way. Okay, so we are going to switch over. Okay, so now we're going to look at the law of sines. Does anyone remember the law of sines at all from high school? Okay. So it's kind of easy once you get the hang of it. It's a pretty powerful tool. So we're going to look at solving side angle angle or angle side angle triangles. We're going to solve side angle triangles and solve some more applied problems. You definitely want to write this down. It's talking about how to solve oblique triangles. Oblique basically meaning that we're going to know some of the angles, and those items that we know should lead us to the other 4 options. It basically just means that we're not dealing with, or we may not always be dealing with, a right triangle from this point forward. We may not know what we're dealing with there, okay? So go ahead and write that down. You can just kind of write it in your own words. I would definitely draw out the oblique triangle. Make sure you know that you're working with items that are not including a right triangle. You guys are good to keep going. So this slide is extremely important. If you're watching it on the recording, pause it, write it down. Those of you in class live. So one of the questions we always get when we're teaching this kind of lesson is there's a portion or type or case that you can look at there and you can tell it doesn't exist. Can anyone pick it out? As they, go ahead, what is it?
The second case.
Well, so the second case is considered an ambiguous case, and we are going to talk about that, but it's not listed as, it's not a fifth case. I'll put it that way. So it's not one that's currently listed, and there's a reason for it. Does anyone have an idea? My hint to you is that when we teach this to younger students, we always tell them that it doesn't exist because it would be a bad word. Yeah, I think you guys got it. So angle, side, side is not, doesn't exist. There's no way we can really work with that. So you could sit here all day and honestly, you're not going to get anywhere. I mean, even the only way it could really help you is if it would be a right triangle, but that's really not what we're working with here, and that would be considered something else. So, so yes, angle, side, side does not exist. And when you teach it to little kids, that's basically the reasoning you give them. They chuckle a little bit and then, you know, you move on. Okay, so we're going to work with law of sines. So that is our theorem. Do you guys need me to go back for a few seconds? Did you need the cases again? You can get it later through the recording. Okay, so we're going to work on law of sines. For a triangle with sides A, B, C, and the opposite angles A, B, C respectively, you can see the equalities there. Sine A over A equals sine B over B equals sine C over C. Law of sines is probably one of the easier things to memorize if you were going to memorize things for me. Like I said, you pretty much don't need to because you can use the cheat sheet. So law of sines is used to solve triangles for cases 1 and 2. And like I said before, case 2 is an interesting case. So as you can see, the law of sines actually consists of 3 equalities. Sine A over A equals sine B over B, sine A over A equals sine C over C, and sine B over B equals sine C over C. You can write them either way. You can memorize them either way. We're going to end up using them in all kinds of scenarios. So I don't think you'll have a hard time memorizing them. All right, and then the second thing they're showing you here is that A plus B plus C, your 3 angles together for a triangle will always give you 180 degrees. That may seem simple, but it is going to come in handy when you guys look at things. All right, so let's move on to some examples. Okay, so if we were going to solve for a triangle given 45 degrees, 55 degrees, and a equals 5, does anyone want to be brave and do that in the whiteboard other than me? I know I'm brave. I eat at buffets all the time, so I got the brave factor down. I just don't know if anybody else is brave. If you want to do it, let me know, because then I can change the share setting. No? Okay, I can do it. Okay, so we were given the following information. Given, where are we at? A equals 45 degrees, B equals 55 degrees, and A equals 5. So what do you notice is going to be really nice with this problem? Before we do anything else, what do you notice about, if you're considering the law of sines, what should you notice right now?
Sine of 45 divided by 5 is equal to sine of 55 divided by b.
Right, so that's going to help us find B. But what's nice is that you have big A and little a, which means right away you should know you're going to be able to use law of sines. So before we find B, let's find the last angle. So to find C, right, we're going to take C equals 180 degrees minus A, which is 45, minus B, which is 55. So what is our C going to be? Our big C. Right, 80 degrees. Excellent. Okay, so that's the first one. And I could sit here and draw you out my triangle. I highly recommend that you guys draw out your triangles. You can see my notebook sometime if you want. I can take pictures. I sit here and I draw them all out, but to draw them up on the whiteboard is just going to annoy you guys, so I'm not going to worry about it. All right, so the next thing we're going to look at is we're going to actually use the law of sines twice. Okay, we're going to use it to find little b, and we're also going to use it to find little a. Or I'm sorry, not little a, little c. Okay, so we're going to do sine of a over a equals sine of b over b. But now we can also use sine of a over a to find sine of c over c. If you guys remember back to algebra, you know how when you would solve problems, a lot of times teachers would tell you, don't ever use an unknown to help you find another unknown. You know, you're always supposed to go back to what you're given in order to find unknowns. Not really the case here. You almost always use an unknown to help you find another unknown. But I believe the reason behind that is because you know that you have to have a triangle equal to 180 degrees. So that's kind of like given information in a way. So I guess that's why they're okay with you doing it this way. All right, so once we plug in all of our information, B is going to be equal to what? 5 sine of 55 degrees divided by the sine of 45 degrees. So then B is approximately 5.79. Okay. And similarly, if we plug in, we're going to end up with 5 sine of 80 degrees divided by sine of 45 degrees. So C is approximately 6.96. Okay. Like I said, go through, make sure you draw your diagrams. I just know that I'll have a hard time drawing them in the whiteboard. All right, are we good with this one? Okay. All right, let's do another one. The next example gives you, if we're given A equals 20 degrees, B equals 25 degrees, and C equals 4. All right. So the first thing we can find is what? We have 2 angles there. So what do you think the easiest thing is to do first?
Finding C.
Find C. Yep. Okay. So you're going to take 180 degrees and you're going to subtract 20 and then subtract 25 and you'll end up with big C. So big C is equal to what? Okay. So now if we rewrite to find A, we're going to end up with 4 sine of 20 degrees divided by the sine of 135 degrees. So A is approximately, I'll give you that guys time to figure that out without me for a second while I write what B is. So A is going to be about 1.93 and B is about 2.39. Here's some caveats. Make sure that you're using degrees and not radians. Almost all triangle trig at this point should be in degrees and not radians. If it gives it to you in radians, then obviously use it, but otherwise I would suggest giving it in degrees. Okay, so that is a second example. Let's switch back to the PowerPoint. Okay. We'll just, for the sake of the recording, we'll go through these really quickly so people can have the slides to pause on if they want it. We just did this example in the second example. All right, so now we're gonna go to objective 2, which is solving side angle triangles. And here's where we're talking about when we want to talk about case number 2, it's considered that ambiguous case. And the reason for that is because you can have one triangle that could be a right angle. You could have one triangle that isn't a right angle. You can have two triangles in one, or you could have no triangle at all. So I would definitely take the time and write this out. Okay, so make sure you pay attention to that. If A is less than H, then we have no triangle. If A is equal to H, then we have a right triangle. All right. Okay, and then here's your two other options. You can have B of sine of A less than A and A less than B, and you're going to end up with two triangles. So two triangles in one. And the last option is a one triangle, but it is not a right triangle. And that's when A is greater than or equal to B. Okay? Make sure if you're... Okay, so we're going to look at this example over in the whiteboard. Okay, if we're given A equals 2, C equals 1, and big C equals 50 degrees. Okay, so the first thing you can do here is we can use law of sines because we need to find big A. And we know big C and little c. Okay, so now we can plug everything in. So sine A over 2 equals sine 50 degrees over 1. So essentially, A is equal to the sine inverse of 2 sine 50 degrees, which is about 1.53. Now, I want you guys to consider what this is saying for a moment. We have an angle whose sine is supposed to be 1.53. What do you think that means to you? What can you take away from that statement?
Doesn't it fall out of the range?
Right. So we're going to say because sine cannot be greater than 1, there is no triangle. Additionally, no matter what the length of B would be found as, it could never connect to C. Okay. Right. So because of our understanding of sine, we know that that triangle will not exist. All right. So we're going to do another one. Given A equals 4, B equals 3, and A equals 60 degrees, what's the first thing we can find pretty easily?
We could easily find a small c, wouldn't we?
If we were doing a right triangle, yes, but we're doing an oblique triangle. So before we go looking for small c, we have little a and big A. So that should scream law of sines at you. Okay. So let's do sine of A over little a. And then what's the third unknown that they gave, or the third known that they gave you? They gave you little b. So that means we can find angle B. Okay. So if we're looking for angle B, we're going to rearrange. And if you plug everything in, you end up getting 3 sine of 60 degrees. Oh, I'm sorry, guys. I wrote that wrong in the given. My apologies. Hold on a second. It should be a 3. Okay. Over 4. All right. And then, but here's the interesting part. When you figure this out, you actually are going to find out that you have a B1 option and a B2 option. The first option is 40.5 degrees. And then if you take that from 180, you actually will find that you have a second angle option, which is 139.5 degrees. But what do you guys need to keep in mind? A plus B has to equal what?
C.
Not just C. So A plus B has to equal 100, or it has to equal 90, right? So regardless, it has to be less than 180 degrees because A plus B plus C equals 180 degrees. But if we look at this, A plus B sub 2, wouldn't that be greater than 180 degrees? If you take 60 and add it to 139.5, are we over 180 degrees? Yes. So because of that, this is not a viable option. Okay. So no. All right. Oh no, did not want to do that. Okay, that's still there. Great. All right. So now that we have that option done, we can now find big C. So if we're going to find big C, all right, we can take A, which is 60 degrees, And B, which we just found, is 40.5 degrees away from 180. So we end up with C equal to 79.5 degrees. Now, Braden, we can find little c, right? Okay. So we're going to use law of sines again. And I would stick with A because A is what you had both for. Okay, if you rewrite it, little c ends up being 4 sine of 79.5 degrees over sine of 60 degrees. So C is approximately 4.54. Do we kind of see how case 2 can be ambiguous and how we can kind of have two different options a little bit? Because of the angles being able to find two different options, you can actually end up with two different triangles. Okay, so we have another example. Given, oh, that's not the word given. Try again. Wow, cannot write today. All right, given A equals 7, B equals 9, and A equals 40 degrees. We have to find everything else. So what are we going to do? Where should you guys start first? What do you notice you have again?
You can find B because you have both A's.
Right, so we're going to use law of sines again. Okay, we know sine A and little a, and we want to find angle B because we were given little b. All right. What do you think is going to happen when we do this? Do you think there's going to be a chance that we can find two betas or two b's again? There is, right? So B1 ends up being 55.7 degrees. So if you take that from 180, you end up with 124.3 degrees. Now, what do you notice about angle A? Angle A is acute, right? So either of these options qualify. Okay, so that means if you add B1 to 40 degrees, or if you add B2 to 40 degrees, you're still going to end up with viable options, okay? So that just means that we now have to find C1 and C2. So C1 is going to be 180 degrees minus A, and then minus B1. And C2 is going to be 180 degrees minus A, and then minus B2. So C1, if you plug in, ends up being 84.3 degrees. And then C2 ends up being 15.7 degrees. That is a 7. Okay. So now we're going to use law of sines, and we have to find little c twice, actually. All right. Make sure you guys are definitely paying attention to this example. Okay, so we're going to use sine of 60 degrees over 7 is going to give you sine of 84.3 degrees. And you get little c1. Excuse me. Which, if you work that out, ends up being 10.84. And then if you do it again, you have sine of 60 degrees over 7 equals sine of 15.7 over C2. And C2 ends up working to be 2.95. Okay, so what you guys need to be careful of is when you were to draw this, you would actually draw it as one triangle. It just happens to be 2. So let's take a look real quick at what that looks like. Okay, so we're just gonna kind of go slow again for people watching on the recording. They can hit pause. All right, so here was the example where we're looking at 2 different angles for B, 2 different angles for C, and 2 little c's. Look at their overall diagram here, okay? It is 2 triangles, but it is in one drawing, okay? All right, we're almost done. All right, we're going to power through the rest of this. All right, so we're going to solve some applied problems. All right, take a look at example 6. All right, to measure the height of a mountain, a surveyor takes 2 sightings of the peak at a distance of 900 meters apart. This was very close to one of the problems on your exam. The first observation results in the angle of elevation at 47 degrees, and the second results in an angle of elevation at 35 degrees. If the transit is 2 meters high, what is the height of the mountain? Okay, so go ahead and draw your diagram out. Okay, so let's take a look at the solution. So since we have the given triangle there, we're going to use law of sines. Okay, so sine A over A equals sine C over C. So then little c works out to be roughly 3,165.86 meters. Now, how did everybody follow through how they found their degrees? Okay. All right. So if we use the larger right triangle, we're going to end up with sine of 35 degrees. So finding B. And B equals approximately 1,816 meters. So then the height of the peak from the ground is approximately 1,818 meters high. Okay, you have to write it out as a sentence because this is an application problem. All right. I don't care what kind of sentence it is, as long as you take the time to write it out. Okay. All right, let's look at the last example. We're looking at example number 7, and it is a rescue at sea. It's the last example that we're going to have for today. Thank you all for working with me so hard so we could get through both lessons. So what are we looking at? The Coast Guard Station Zulu is located 100 miles due west of Station X-Ray. A ship at sea sends an SOS call that is received by each station. The call to Station Zulu indicates that the bearing of the ship from Zulu is north 50 degrees east, so 50 degrees east of north. The call to Station X-Ray indicates that the bearing of the ship from X-Ray is 60 degrees west of north. So I don't know about you guys, but if you remember back to doing the SATs, this is on the SATs like all over the place. Okay. How far is each ship station from the ship? And if a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long will it take to reach the ship? Okay, so whether you're watching the recording or you're here with me live, make sure you draw out your diagram. I'll give you a few minutes to do that. I do want us to make sure that we get through this on. Okay, so for part A, we're looking to find angle C. How do we know that's correct? So we're just going to take 180 degrees and we're going to subtract 40 degrees and 30 degrees. Okay, so C is going to be equal to 110 degrees. All right. now that we have that, we can go through and find our mileage for each of the ships. What I want you guys to keep note of here is look how they made a nice sentence there. You absolutely need that if you're doing a problem like this, okay? I really want you guys to make sure that when you're working application problems, you're really working them out, all right? Okay, so they find their mileage from the two distances by finding little a and little b. So they use law of sines twice. Okay, so sine of 40 degrees over a equals sine of 110 degrees over 100 miles. So then A ends up being roughly 68.40 miles. And you guys can see there that B ends up being 53.21 miles. Okay. All right. So for part B, this is the last slide. The time T needed for the helicopter to reach the ship from Station Zulu is found by using the formula rate times time equals distance. I don't know why they chose to make it a B. I would have used a capital D or a lowercase d. Maybe they meant to. I've never seen a distance formula using a B. So if I were you guys, I would just use a capital D or a lowercase d. Then we take time and we're gonna find it by taking the distance divided by, oh, you know what? They might have used B because little b is equal to 53.21. Up to you. As long as you know they're equivalent, that's all I would care about. So it equals about 0.27 of an hour or 16 minutes for the helicopter to reach the ship. Again, they're choosing to write out a sentence. I think that's extremely important. Okay. Do we have, so you want to make sure you work on your Chapter 8 exam, finish your Chapter 8 quiz if you haven't done that yet, finish any homework for Chapter 8, and then if you have any time, I would definitely start working on Chapter 9.1 and 9.2 homework. So on Monday, we will pick up with 9.3, and I'm not sure if that's the one that's 66 slides or not, so we may or may not finish it. All right, I will see you all on Monday. Have a great, lovely weekend.